In this series, we will cover the many ways HEEDS enables you to discover better product designs faster by automating the exploration of your simulation models. Today, I will be showing you how to use the ANSYS Workbench portal with HEEDS to quickly set up an optimization study and allow HEEDS to drive the design space exploration. I will start with an ANSYS model and tell HEEDS how to automatically modify the inputs and monitor the outputs in an effort to discover a design that better meets the desired objective. There are two separate ways to use ANSYS for a design exploration study. The first is to utilize the embedded CAD program Design Modeler. The second would be to use an external CAD package to draw your design and use ANSYS as the CAE tool. In order to do option 2, you must have the associative workbench interface, which allows ANSYS to read the parameters of the original CAD file and modify the design accordingly. The process for manipulating the geometry once inside of ANSYS would be the same for the two ways described before. For more questions regarding the ANSYS Associative Workbench interface, please contact your ANSYS support representative or consult the Workbench Help Manual. To start, we'll open up ANSYS Workbench, and here I have a model done in static structural. The process would be the same for any one of the analysis tools inside of ANSYS Workbench. And we can see here that the model has been simulated and has a working solution. So now we need to go in and define the input variables and the output responses that HEEDS is going to use for its optimization routine. And so to start, we're going to double click on the geometry and open up the Design Modeler. And in here we can see the design that we currently have for this study, and it's just a simple torque arm. And here we have the different dimensions are defined here as well. And what we want to do is we want to have HEEDS modify the length and location of this slot as well as the radii that are involved in that. And so to do that, we're going to come over to the details view where we have all of the different dimensions defined here. And we're going to choose the variables of importance. And so to start, we're going to modify the value that ANSYS calls H10, which is the first location of the slot. And so in order to get HEEDS to be able to modify it, we have to define this as what's called a parameter inside of ANSYS. And so to do that, you just check the box next to the name of the variable. And so checking that box allows you to change the parameter name. And so for this case, we're going to call it X1. And it's important to define your parameter names because when you get into HEEDS, you're going to have to know which of these variables is X1, and you may not remember what H10 happens to be. And so it's important to name it something that you're going to remember. And so for this case, we're going to name X1. And then the length of the slot here is defined in ANSYS as H7. We're going to call that X2. So again, we just check the box next to H7. And we're going to call that X2. The same, we're going to define the first radius of the slot, and we're going to call that one R1. So click on the box and just define that as R1. And the second radius as well, which is R9 in ANSYS, we're going to call R2. And we'll see where that comes into play later when we do the tagging portion in HEEDS. So now that we have these four variables, X1, X2, R1 and R2 defined inside of the design modeler, we can see how that affects our ANSYS Workbench model. So when we go back, we can see how we have a parameter set defined here, and we have input variables that are coming in and modifying the design. So now that we have that, we need to define the output responses that HEEDS is going to be able to monitor. And so to do that, we just double click on Model. And that'll open up the static structural analysis. And again, we can see our torque arm. And so to start, what we're going to do here in this optimization study is we want to have HEEDS be able to find the minimal mass for a given maximum stress. And so typically, you're designing a part and you have a factor of safety of say 10%. So you want the maximum stress to be within a specific range. And so our two main output responses that we are concerned with here are mass and maximum stress. And so to find mass, we click on geometry and we go down into the details view and we see a properties tab here and we just open that, and then you'll see mass, and again we just check that. Now for the mass, you don't have to change the name because ANSYS will automatically export the name as geometry mass, and so it's easy to tell when you're tagging what mass is and what stress is. And so since we've already created an equivalent stress analysis here, we just click on that and scroll down, and we can see in the details view our maximum stress here, and we just export that as well. So we have both our mass and our stress is exported, and then when we go back into Workbench, we'll see here how we have input variables coming in and we have output responses going to the parameter set as well. Once we've defined the variables that we're concerned with modifying and the output responses that we want HEEDS to be able to read, we just go ahead and save this model. And then we can open up HEEDS. And so inside of HEEDS, the first thing that we need to do is we need to define that we're using ANSYS. And so we activate our ANSYS portal by selecting it from the portal dropdown or in the list above of all the portals. Next, we need to determine what our input and our output files are. And so for ANSYS Workbench, our input and output files are the same, the Workbench project files. And so to do that, we would just right-click and add input file and right-click and add output file. And you can see here how I've already done that with the Workbench files that we have here. And so next, we're going to define the parameters. And I have here already defined my X1, X2, R1, and R2 values here, as well as defining the minimum and maximum values that are allowed. And I also have my baseline values, which correspond directly to the analysis that we've already set up inside of ANSYS. And that's important to do because we want to make sure that our initial design is a valid design. We don't want to have any errors. So once I've defined my 4 variables, I need to define my responses as well. And those are, as we mentioned, mass and maximum stress. So I have those defined there. Now I have the HEEDS define the inputs and the output variables. I need HEEDS to know exactly where to look inside of ANSYS for those. And so to do that, we're going to go to the tagging tab. And so inside of the tagging tab, I have my input file selected. You can tell it's the input file by the green arrow. The blue arrow corresponds to the output files. And we can see here the different things inside of that parameter set that we have defined. And so we see the X1, X2, R1, and R2 values. And so I'm going to tag my X1 value here. So I've determined that my X1 variable is the variable of choice here. And so I click on the cell of importance and I just click tag. And since I have auto advance on, it goes to the next variable, which is X2, as well as the next cell, which also happens to be X2. So I can tag X2, same for R1 and R1, so I can tag those, and R2 and R2, so I can tag those as well. So now I have my input file tagged with all the variables of importance, and now I'm going to go to my output file. Clicking on parameter, we can see that mass is selected here, and we can see the surface body mass here. So we select that and tag, and then maximum stress here as well. And so that shows you the use of the ANSYS Workbench portal.